The next things have to do with the fact that a logarithm is an exponent. Just a quick example to illustrate why this is going to work the way it does. Example, we're going to just quickly review exponents a little bit here. If I want to find x to the third times x to the second, I add the exponents, right? And the answer would be x to the fifth. So the exponents are added together to get the result. Likewise, if I wanted to divide, like let's say I had x to the seventh divided by x to the fourth, it's just subtracting the exponents when it's division. So we'd have 7 minus 4, which leave us with x to the third. So now because logarithms are exponents, they're going to behave that same way. Multiplying is actually the same thing as adding, and dividing is the same thing as subtracting. Let me show you with the actual formulas, and then we will do some examples. Okay, so the properties here are if you have parts within the logarithm that are multiplying, you can expand that logarithm into separate logarithms by adding the pieces together. So log base a of m plus log base a of n. That would be expanding the logarithm. Or sometimes they might call it writing it as the sum or difference of logs. Okay. Likewise, for the multiplication is the division. So if we have parts within the logarithm that are dividing, we can split that up into separate logarithms by using subtraction. Now, we're learning these properties right now so that we can then use them in the next section to solve problems. So there will be a purpose for them later. So just bear with me on needing to learn them so that we can then use them later. Okay? We probably ought to do some sort of example at this point of expanding now that we've learned these properties, or putting them back together into single logarithms. Okay, so let's try log base 3, and let's do x. I'm making something up here. I shouldn't have done that because now I'm winging it. Okay, let's go ahead and do that one. So if I wanted to expand the logarithm, I would split up individual things that are multiplying in here. So that means I would need to factor it first if it's not already factored. So then we would have log base 3 of x plus log base 3 of x minus 3. Because x times x minus 3 is x squared minus 3x. So since those individual pieces are multiplying to get that, if I want to expand the logarithm, I split it up into its individual factors. Now just like we've done before, these are terms, not factors, so we cannot split this up any further. It has to stay like that. Let's look at some other examples. Let's try something with division and with some exponents in it here. This one is quite a bit more complicated. I'm just going to call it log base a, meaning it doesn't really matter what the base is or whatever. Okay, so we have two things that are multiplying in here, and we have this item that will not factor. So the first thing is just to string out or separate out the parts that are factors that are multiplying together. So that would be done like that. Okay? Now the second thing is actually a property I just realized I haven't taught you yet. So we need to go back a little bit, and here's another property really fast. This one is the power property, has to do with taking a power, putting a power on a logarithm. If I have a logarithm with a power, remember a logarithm already is a power, it's an exponent. So a logarithm that's already an exponent with an additional power on it means we're taking a power to a power. So for example, if we have like x to the third to the, I don't know, fourth, we multiply those powers together to find the answer. So that would be x to the 12th, correct? So we multiply. So if we want to use that same principle here, this is a power and this is a power. So in order to simplify that, we just simply multiply the powers together. So it would be this power times that power instead of this to a power. So to show that multiplication more easily, we actually take that power and move it out front to multiply it out there instead. So it's kind of more a separate factor. You don't need the dot to indicate the multiplication. You can just put it there in front, and it means that it's multiplying. This is one thing, and this is one thing, and the two things are multiplying together. Okay? So we're going to use this property on this problem by changing our square root to a power. So a square root is a 1/2 power. So I'm going to rewrite this whole problem as x squared plus 1 to the 1/2 power. So now using this property that we just learned, we're going to move this out as a factor, multiplying instead of as a power. We move the powers out to the front, and voila, that one is done. Simplified by writing it as a sum and difference, or sum or difference of squares. It's not squares, sum or difference of logarithms. Okay, one more example. Let's do x squared. Okay, we need a log on this first. We'll just leave it. Okay, so back where I left off, this problem involves both division and exponents. So let's see what we can do with it. First of all, let's separate the division, which would mean it's a subtraction problem. So we take the top, everything that's on the top of the fraction, and then we subtract anything that's on the bottom of the fraction, and of course separate them with individual logarithms. Okay, now we have to deal with the exponents. So this exponent would go out front of this one, and this exponent would go out front of this piece here. Now we cannot separate this x minus 1 any further because it's terms, not factors. And that's our final answer. Now if we have more than one thing that's multiplying or dividing, let's just quickly throw another one together. Let's do a natural log this time. If we had something like, let's do x over y z. Like I just said in the last problem, everything on the top would be positive, anything on the bottom would be negative. In fact, let's just throw another variable in here. Let's do a 3x or something like that so that we have two factors. Okay, so then we would have the natural log of 3 plus the natural log of x minus the natural log of y minus the natural log of z. So notice how everything that was on the top of the fraction is positive terms, and everything that was on the bottom of the fraction is negative terms. And I didn't put any exponents in this one that you would need to put the exponents out front, so it's good the way it is.